Hi everyone. Today we are going to learn a very interesting and a really useful topic in mathematics. That's Pythagorean relation or Pythagoras theorem. Okay, before move on, here is a challenge for you. This is a post fixed on the ground. To balance the post, you need to fix two cables from the top of the column to the ground. It must look like this. If the post is 8 meters tall and the cable is 10 meters long, at which length from the bottom of the post should be the cable be fixed? Can you guess a way to find the answer for this problem? Today's lesson will guide you for this. Pythagoras theorem is based on triangles. Therefore, let's remember something about triangles. What shapes can you identify in this image? Yes, there are 3D shapes like pyramids, diamonds, and tetrahedrons. Yet, what is the 2D shape that you can find on each shape? Correct. They all are made with triangles. Can you name these triangles? Pause the video and give a try. Got them correct? Well done. Else, here is a list of type of triangles for your reference. However, today we are going to focus on right triangles. Why? Right triangles are special triangles with some unique characteristics. Pythagoras identified a very special relationship about 2500 years ago. Amazing, isn't it? Okay, let's remind what we already know about right triangles before moving to the theory. First, can you name the longest side which is opposite to the right angle? And next, what is the total value of x and y angles? Pause the video and give the answer. The opposite side to the right angle is called hypotenuse. Of course, this is the longest side of a right triangle. As you know, right triangle has got its name because it has one right angle in it. The size of a right angle is 90 degrees. Since the sum of all three angles in a triangle is equal to 180 degrees, the sum of other two angles should be 90 as well. Okay, now into the theory. Look at the squares drawn on each side of the triangle. The yellow and green squares are drawn on the sides that create the right angle, while the big square, it is drawn on hypotenuse. The area of the yellow square is a square because the length of a side is a. The area of the green square is b square because the length of a side is b. Like that, the area of the square drawn on the hypotenuse is c square. Pythagoras found that the area of the square drawn on the hypotenuse is equal to the total area of the two squares drawn on the other two sides. This link is considered as the Pythagoras theorem or relation. The concept can be explained with this equation: a square plus b square equal c square. A square is the area of this square, and b square is the area of this square, and c square is the area of this square. Next, let's try an example by applying the theory. In the given example, you can see the lengths of two sides are given. They are 3 and 4 units. We are going to find the length of the hypotenuse using Pythagoras theorem. You can see the equation on the right side. Let's substitute the given values to the equation. It looks like this. Now, let's solve the equation. 3 square equals 9 and 4 square equals 16. The total is equal to c square. The total of 9 and 16 is 25. Thus, c square is equal to 25. We are not going to find the value of c square, but the value of c, which is the length of the hypotenuse here. Then, can you suggest how to find the value of c? Pause the video and think. Got it? Well done. If not, value of c should be equal to the square root of 25. So the answer is, pause the video and give the answer. Excellent. It's 5. If you struggle to find this, please follow the link given under resources for revision of square root. Now, let's work with the given unit. Length of sides are given in centimeters. When these values are substituted, it looks like this. And comes to this stage, 25 square centimeters equal to c square. Therefore, the value of c equals the square root of 25 square centimeters. It is 5 centimeters. Another example. Here you find that c square is equal to 13 square centimeters. It is not a perfect number. Therefore, we can leave the answer as this, square root of 13 square centimeters. If need, we can find the correct answer with decimal. But at the moment, we leave it as it is. Now, it's your chance to practice your own. Look at the figure and find the length of C. Pause the video, take a pen and a paper, then do the sum by filling the blanks as seen on the screen. Likewise, you can use the Pythagoras theorem to find the lengths of other sides of a right triangle. Follow the procedure given on the screen. Here, we can see that the length of hypotenuse and another side is given. We need to find the length of the other side, which is given as A. We use the same equation and substitute the relevant values like this, then we can come to this point where a square is equal to 9 square centimeters. So the answer is the square root of this. It is 3 centimeters. Another challenge for you. Follow the procedure and find the length of the side which is given as B. Pause the video and do your calculations. Excellent work if you could make it correct. Else, here is the solution. The converse of the theorem. The converse of the Pythagoras theorem is the opposite side of it. If the area of the square drawn on the longest side of a triangle is equal to the sum of the areas of squares drawn on the other two sides, then it is a right triangle. Is Pythagoras theorem really a useful tool? Let's see. Most of the construction workers use this theorem to create right angles in building corners without measuring it with the protractor. This is actually the converse of the theorem as we discussed above. They use strings or ropes with lengths corresponding to Pythagoras theorem, as you can see in this image. If the sides of a triangle are corresponded with Pythagoras theorem, it is always a right triangle. Thus, people use a combination of lengths like 3, 4 and 5 and get 90 degrees angles at corners of the building. As this figure shows, a construction worker can use the given length and height to find out the length of wood needed to construct the roof of this building. Since they can take the correct measurement, they do not waste wood. Pythagoras helps save forests. Now, let's find the answer for our first question. What is the length from the bottom of the post to the point where the rope should be fixed to the ground? Post your answer on Google Classroom. Now, follow the link to worksheet for more practice in the Google Classroom. Good luck for the exciting moments in the next meeting.